My name is Jack Resider, and I'm going to talk to you about the art of solving novel problems in Infosec or IT security. So let's get into a few novel problems. There was this video called Despacito, and it was the first video to ever hit 5 billion views on YouTube. What happens when it hit 5 billion views? A hacker deleted it. Yeah. And I wonder who's trying to solve this problem and what would they even do to try to solve this? Like, is this the people who uploaded the video to YouTube's problem? Yeah. I mean, they just got their 5 billion viewed video deleted. Oh my gosh. And of course, the people at YouTube, it's their problem too, because how do you restore the most viewed video ever? It's really complicated, right? So I think a lot of people, when they had this problem, were not sure how to solve this. This was probably a very difficult day for some people because they just don't know. I mean, if you're confident, you know how to fix things like this, then boom, you resolve it. But this doesn't seem like it's something you can easily fix, which kind of makes it a novel problem. But then this tweet came out, which said, hey, YouTube, it's just for fun. I used a script called YouTube Change Title Video, and I just wrote hacked on it. Don't judge me. I love you, YouTube. It turns out that somebody just used some sort of weird API and hacked the API to just change the title of the video. So it appeared to be deleted, but it really wasn't. And that's kind of what happened here. But again, this is a problem that somebody needs to fix. And I don't know if they've ever encountered a problem like this before. Here's another weird problem. There was a pig farm in China, but for some reason there was a rival gang of people who didn't like this pig farm. And so they would come and try to poison these pigs. And one way they would poison the pig was to fly a drone over the pig farm and drop poison pellets, and the pigs would eat the poison pellets and cause disease. This pig farmer didn't like that. But I mean, stop here for a second and recognize this is a Infosec problem already, right? I mean, we've got technology, a drone coming and flying over, poison pellets. This is a technology problem, and somebody who understands technology can fix the problem. And that's exactly what happened. They got an anti-drone gun to point at the sky, look for drones flying over, and shoot them out of the sky as they come over. But this created a new Infosec problem because the commercial flights that were flying over this pig farm were also getting hit by this thing. And they were getting their systems jammed, and it was causing some major problems for flights going over there. There's so many new problems in this scenario that it's mind-boggling, right? I mean, a farmer isn't ever going to think that they need to solve this problem. So this is a new problem for the farmer to solve. And does anyone even know how to solve these kind of problems? So these are kind of, when you work in the IT security space, you're going to hit problems that you've never imagined you'd ever hit. And that's okay, because we're going to learn like ways that you can solve these kind of problems that you've never imagined that you can solve. And they're frustrating. They're really frustrating because you're like, oh, I don't know what to do. I don't know how to solve this. This is new. This is confusing. This is frustrating. And then there's multiple different kinds of novel problems in the world of IT security. Like you can have just a novel problem of something you've never faced before ever, and this is just new to you, or it could be a novel problem that nobody's ever faced before and it's new to the world. And so, there's kind of like a difference of different kind of novel problems. But when you face these things, this presentation is going to kind of help you understand how to solve some of these. So Einstein says we can't solve problems by using the same kind of thinking that we use to create them with. So let's start with that. Let's start with the mindset. Let's change the way we think about problems. There's this great book I read called Mindset, and it talks about there's two different kinds of mindsets we have. We have a fixed mindset and a growth mindset. And you can have one or the other, or a little bit of both, or a hybrid of the two. But I think we generally kind of fall into one side or the other. And somebody with a fixed mindset would say, I'm either good at it or I'm not. But somebody with a growth mindset says, I can learn anything I want. Like, for instance, somebody asked me to dance, and I'm going to say, oh, I'm not a good dancer, and I just leave it at that. But if somebody asks me to dance and I have a growth mindset, I could say, you know what, I'm not good, but I'd love to try. Let me have a shot. And do you have anything that you can teach me how to do to dance better? Somebody with a growth mindset is just more willing to give things a try for the fact that they just want to learn it. Somebody with a fixed mindset would say, oh, I get frustrated and then I just give up when I get frustrated about doing something. But somebody with a growth mindset would say, well, when I get frustrated, I just persevere. I understand when the going gets tough, the tough get going. And, that they don't mind when they get frustrated. They're like, oh yeah, I know that feeling. I've had it before. It'll go away once I just practice it some more. Somebody with a fixed mindset would say, I don't like being challenged. It's just too hard. But somebody with a growth mindset would say, oh, I love challenging myself. Another thing is that the people with fixed mindsets when they see other people succeed, they sort of feel threatened. Like, he can do it, but I can't. That's so frustrating. Like they have that kind of mentality. But people with a growth mindset, they see somebody succeed and they get inspired. They're like, oh my gosh, that was so cool what you did. I want to go do that too. Can you teach me how to do that? That was awesome. You're inspiring me to go do it. And so I think this is the biggest key takeaway is just changing our mindsets. Like say, hey, I know I don't know this problem, this novel problem that I'm approaching, but if I have the right mindset, I can solve it. Like I can totally solve this thing. Another different kind of mindset is one that's called Rosh Katan and Rosh Gadol. This is Israeli. In the Israeli army, they kind of classify you as these two different things, and they identify you in this stuff. So Rosh Katan translates to little head, and Rosh Gadol translates to big head. And what this means is people with Rosh Katan just kind of do what's asked of them, and that's it. They're kind of done. But the people with Rosh Gadol mindset are able to step back and say, well, why are you asking me to do that? Is it because you want this objective complete? Well, if you want that objective complete, I've got another way we can solve that using these other techniques, which I think would use less resources and have just as much of a effective, completion. And so people with Rosh Gadol kind of think out of the box, and they can challenge their superiors. So I'd say, hey, you know what? I know you wanted me to do that, but I did this other thing instead. It has the same results. Do you think it's okay if we do it that way or whatever? They also are able to step back and look around and say, why are we even doing this to begin with? Like, what's the point of doing this? Isn't there something more effective we can do instead to accomplish whatever it is we want to accomplish? So the Rosh Gadol people have this different way of looking at life than Rosh Katan, which to me is very similar to what a junior engineer does and a senior engineer in like an IT security position. Somebody who's a junior engineer will wait till somebody tells them to do something, and then they might rush to do it. They'll get all the things done. I mean, I've seen really amazing junior engineers who can run circles around senior engineers seemingly, right? They're like, I can do all the things a senior engineer can do, and I can do it faster, or, I can do it better or whatever like that. And it might be true. So what's the real difference between a junior engineer and a senior engineer? Well, the senior engineer is able to not only get their work done, but also take a step back and say, well, what does the company need next? What would be the most beneficial for this company? And they can come up with things, really helpful things for the business. They can think in business terms like, oh, if we had this offering for our clients, then that might bring in more value to us. Or if we were able to streamline this process, we could then become more efficient at our jobs. And so senior engineers kind of make these big brushstrokes of, let's make these changes to the organization that can really benefit us as a team or as a business, while the junior engineer is just kind of waiting for the next thing to land on her plate and then rush to do it and get it done and say, okay, give me another thing. And they don't quite see these things, on a bigger picture. So let's talk about my journey for a little bit. I was an engineer, a security engineer in a managed service provider. So I was dealing with a lot of different clients and stuff. And, I came on board as a engineer in training. I wasn't even quite an engineer yet. I was being trained up to be an engineer. Actually, I came on board as a technician, but then when I got to an engineering position, that's where I started as an engineer. But I had a few goals at the beginning. First, I was new to the engineering team. All these people on my team were really good. I was just learning. So I was like, okay, how do I become a value add? Obviously, I'm kind of the anchor that everyone's pulling behind their ship. And I want to not do that. I want to actually help, put wind in the sails. So I said, well, what's a technology that my team doesn't like doing or hates doing or has trouble figuring out? And I learned, there was a particular technology they didn't like doing that came up sometimes. And they're like, oh, I hate solving that problem. And so I took it upon myself to learn everything I could about that particular problem and technology. So anytime that came up, I would say, hey, can I have that? Can I do that? Can I troubleshoot that? And then I quickly became a value add to the team, much faster than I think normal, because now they were very happy to give me these things that they didn't like doing and saying, oh, yeah, you troubleshoot that one. Cool. Go ahead. Go for it. And I became really good at it, better than even the seniors at that particular problem, because that became kind of my specialty. And so I became a value add in that space. Another thing I like doing as a junior engineer was getting other teams to want me to join their team. So like, I was on the security team, but maybe there's an infrastructure team or another IT team. And if I could help them enough or show value to them or they liked me enough, I would love it if their manager were to go to my manager and say, hey, we want to get Jack on our team. We want him to join us. Is that possible? Because I knew if I could get that, then my pay rate would probably go up. It's kind of like my manager would decide, wow, I'm not utilizing this guy enough. We need to bump him up to senior engineer, or I need to, or I could just fulfill the request of like, oh yeah, I'll go over to that other team, but you have to pay me more. Otherwise I'm going to stay here, kind of thing. So I knew by helping out other teams, it would really help my career in the long run. Another thing that I looked at was, what's the highest position, highest technical position in my company. And at the time, that position was SME, subject matter expert. And what that meant was, I didn't know what that meant. I was like, what is a SME? And I looked at the job description of a SME, and it said that a subject matter expert is the backstop for all technical issues in their domain of expertise. And that stood out to me. I was like, wait a minute, let's read that again. Backstop? What's a backstop? Nothing can get past the SME when it comes to technical problems. And that just fascinated me. How could somebody be a backstop? Nothing can possibly get past them. There's no escalation point higher than a SME. They have to be able to solve all the things. And how can somebody know all the things? That's impossible to know all the things. That's just physically not possible. They can't know all the answers to all the problems, because there's new products coming out. There's new bugs. There's new technologies. They just can't learn it that fast to know it all. So what a SME does is they have the ability to solve problems that they don't know how to solve. And that is a fascinating concept. And they can use resources that they find in other places, or they can practice it. They've got tools to solve problems that they don't know how to solve, because they have to be the backstop. Nothing can get past them. And so with that, I decided to be my own SME as a junior engineer. I was like, any technical problem that comes to me, I'm not going to try to hand it to someone else and say, hey, can you solve this for me or whatever. Instead, I would say, no, I want to learn the tools to solve this thing. And I kind of took this mindset on as my own SME to be, be the person that can solve any problem that came my way. Or even I would even take on extra problems that didn't look like mine. And, there's other things where, like, if, there was another team that had a problem and I had a problem similar, right? Then, like, whose problem is this? Is it their team's problem or my team's problem? I would say, because sometimes two different technologies are not working together. And so it's tough to know whose side of the problem is it on. And so I would take these problems on and say, no, let me try to solve the entire thing. I know it might be your problem, but I want to look into and try to figure out where exactly the problem is. And so I would really try to pull that into me and say, okay, I'm going to figure this out. I'm going to take on a lot more of this role than a normal junior engineer might do, because I had this mindset that I didn't want any problem to get past me. I didn't want to feel like I couldn't solve anything. If I couldn't solve it, I would just find the resources to solve it. These are some people who are kind of influential to me on this journey as well. Grace Hopper, she was one of the early, computer programmers that she invented stuff that kind of led to the COBOL programming language. And she's not somebody who ever said, oh, I was just never trained on that. I don't know anything about that. I can't do that. No, she had the opposite mindset. She was like, oh, wow, let's see what we can do with this. Let's try some new stuff. Let's experiment. Dr. Shirley Jackson, some say that she invented things like a fax machine and call waiting and fiber optics and solar panels while working at AT&T and Bell Labs. And inventors like that, they're not people who say, this is too challenging for me, or I'm frustrated with this. They just say, yeah, this challenge is great. Let's see if we can overcome this. Ada Lovelace, she was born in like 1809 or 1815 or something. And, when she first started hearing about early computers, she realized, they can do more than just adding and subtracting. Like, she had a vision for how they can do, more complex computational things in the 1800s. Like, she had this vision for it. And she wasn't someone who just kind of dismissed it because she just didn't think she could do it. No, she took things upon herself that nobody was taking upon. And the same thing with Hedy Lamarr. She was an actress in Hollywood, but in her spare time, she would practice like wireless communications, which kind of, her work kind of led to the invention of Wi-Fi today. So, these people, they didn't feel like they had this mental roadblock of like, oh, I'm not going to do that, or I can't do that. They plowed right on through that roadblock and said, let's go to new frontiers and experience new things that, invent new things that nobody's invented before. And that is very inspirational. And that's the kind of mindset that I try to embody when I'm handling some novel problems. And when you're dealing with novel problems you've never faced before and don't know how to solve, you've got to realize you're on a frontier here. You're on a journey, a mission that nobody's come to before. At least you haven't come to in your own sense, and you can't simply wait for the rain to go away and all the answers to come to you for you to solve this. You've got to learn how to go through the rain, and it might be stormy, but you've got to figure out a way to just dance in it and feel good about, being in a crazy world. So there's different kinds of novel problems. There's big unsolved problems that nobody's ever solved. Like, if you're on the Wi-Fi, somebody can de-authenticate you and you can get kicked off Wi-Fi. And we really don't have a good solution to kind of protect against this. And the same thing with Microsoft Authentication. Mimikatz is a tool that seems to bypass Microsoft Authentication quite well and has done so for almost 10 years now. Like, it almost seems like authentication is never going to be fixed. And it's always going to be a problem. And this is a big, big novel problem that I don't know will ever get fixed. Secure elections is still a big problem. Like, there's slot machines in Las Vegas are pretty secure, but voting machines aren't even close to the level of security a slot machine is. And I think that might be because there's not enough money getting put into elections and stuff. And so, this is a big unsolved problem that we don't know how to do. Or people are talking about, voting on the blockchain and stuff like this. And there's lots of, problems that need to be solved here. And then there's post-quantum cryptography, when computers can run 1 million times faster than what we have today. What does that look like for cryptography? Because everything's going to be cracked like instantly. So how do you make a, something secure that even a quantum computer can't crack? And these are problems that nobody can solve. And everyone in the world is going to need to solve at some point. But then there are little unsolved problems. So it's the problems that only are a problem to you or your business or your team. Like, for instance, I had a problem where a packet would not travel through a firewall properly. The firewall kept dropping it, and I had no idea why. I asked everyone on my team. Nobody could figure it out. I asked tech support. Tech support couldn't figure it out. I looked online. Nobody online had a solution to this. Like, it was driving me insane. It turned out to be a bug in the operating system, and that's why there was that problem. But still, it was like, how do I solve this that I don't know how to solve? Like, there's a solution somewhere, and I don't know where that solution is, and I've got to find that solution, right? So that's, you're traveling in areas that just seem dark and weird. And I had another problem where a server would go down every Friday at 7 p.m. And I was like, why is this happening? Why, like, where in the troubleshooting guide does it tell you how to troubleshoot something that goes down every night at 7 p.m.? There's no troubleshooting guide that says that. And so it turned out that that office where that server was would just turn the power off of the whole building every night at, every weekend. And so, to save electricity because it was in another country. And so, that was just what I had to figure out, and it was hard to figure out. One time when I was in high school, I got a message on my own computer that said, "Hello, I can see you." And I actually responded like, "Who are you?" And I had a conversation with this person. So somebody had gotten into my computer and was messaging me, and I had no idea what in the world was happening. And so I had to try to figure that out. Like, how do I keep people from getting into my computer and, messaging me? And it turns out I had some ports open. I mean, this was a long time ago where computers were online, had public IPs and stuff like that. So it was just that I had the wrong configuration on my computer. I needed to secure it. So, I mean, you go from being in pitch dark on some of these things to shining your flashlight around to try to figure out what to do. And here's some techniques on how to sort of solve some of these problems. So first, you've got to learn how to do effective research. This is pretty much just like going to Google and saying, okay, here's my problem. Does anyone know how to solve it? Just knowing how to Google things properly is kind of a trick. It just takes practice. But then you got to know where are the kind of the definitive answers, right? So maybe Stack Overflow might have some answers. Maybe the vendor that you're troubleshooting has some guides and documentation and white papers and stuff on how to configure things. And you can, go to their website to try to get some answers as well. Some vendors are hard to get documentation out of, but, others are easier. So, just learning how to use online tools to find some answers. That's really helpful. Another thing I like to really do is map it out, especially if it's a network issue. Like, did this packet travel through this router? Yes. Okay. Did it get through this switch? Yes. Did it get through this firewall? No. Okay. So there's a problem there. And another network troubleshooting technique I like to use is if something's not, traffic's not getting to where it goes, first I like to ping my own device, my own interface where I'm at, then I'll ping the default gateway, and then I'll ping the destination, and just kind of like writing down which ones worked and which ones didn't work will tell you kind of where the problem is, right? So if you can map it out in some way, you can then narrow that problem to just that specific area of, where that's exactly where the problem is. So mapping out, I think, is very helpful for me. But then we've got to learn and practice. So when you're learning, you're taking courses, you're studying, you're opening books, you're watching videos, and then you got to practice that. Just going through the learning process is not enough. You've got to sit down and say, okay, let's do this in the lab now. Let me see what happens if I change these parameters or break this thing. Then how does that look when that's broken? And you kind of practice with the stuff you've learned. Just learning is not quite enough. You've got to practice once you learn. And what you're really doing here is when you're facing a problem you've never faced before, you really are, you're in the dark, and you've got to shine your light in the places that you don't know exist, right? So you're like, okay, there's this whole technology. I don't understand this part of the problem. Let's shine our light in there so I can absorb as much as I can about that information, right? So now I have a better understanding of of what's possible and what that technology does and how to configure it and troubleshoot it and break it and fix it. And so you got to, kind of level yourself up on that particular piece of, technology, and then kind of iterate from that. So if you've got that far, if you did the research and you did the mapping and you did the learning and you did the practice and it still didn't solve your problem, do it again, right? So now when you go back to Google, you have a lot better understanding of what this problem is, because you've narrowed it down. You have a more rich understanding of the language it takes to kind of describe the problem, and so you can use different Google searches or look in different places for documentation. And if that still doesn't work, now you can map it in a new way, get more detailed, get more specific, narrow the problem down even further. And if that doesn't work, you can, learn some more. Take on a parallel problem and try a parallel piece of technology and say, okay, this is similar. Let's see if we can learn that, and maybe that will help us understand this. And so you just keep iterating through this kind of process until you can come up with a solution. Another thing that I think is important is learning how to test properly. If it's sometimes problems are kind of like a Rubik's Cube where you solve one, but it breaks the other side. And so, having a good testing procedure is good, and say, okay, we got that up, that's working, but now do all these other things work too? And so you kind of want to do having some sort of monitoring tools to say, okay, when I make these changes, when I, do these config changes, does that affect or impact other stuff that's going on? And just having a way to test things, I think, is good. You can, ping things, you can run scripts, you can run programs to have monitoring tools, stuff to just kind of give you a sense of what's going on out there when I make these kind of changes, to know if you're getting closer or not to solving the problem. Of course, logs and monitoring is a really big help. Oftentimes somebody tells me a problem and I say, well, what do the logs say? And they say, well, we don't have logging turned on. And I say, well, that's the first thing we should be doing, right? So logs have a lot of information on what happened to this computer and what things happened after and what led up to it. And it really paints a good picture. And you can turn logging on to be even more verbose and see even more information, more detailed. And, this is really helpful for a lot of things. And of course, monitoring. If there's any sort of tools that can help you monitor, on a 24/7 basis to see, okay, we've got it fixed now, but how stable is it? How steady is it? Is it going to crash again or something? And so having some sort of way to say, oh, it only crashes in these particular hours of the day. Like if it only goes down at 7 p.m. at night on a Friday, knowing that kind of information really helps by monitoring it as best you can. And of course, you always should have resources that you can contact for help, right? So you've got your coworkers, your senior people that work with you. Then there's also tech support. So a lot of the products that you're troubleshooting at work, they're under warranty or whatever. You can call tech support and ask for help from them and say, hey, here's the problem I'm facing. What do you think? There's also online resources, right? There's Stack Overflow, there's Reddit, there's all kinds of places online to get assistance. So always know that you can reach out to certain people to get additional help, but you may not want to reach out to the same person all the time because they might get sick of you. I had one guy who would reach out to me all the time, and I'm like, well, why don't you ask other people as well? Like, why are you always asking me? But I was always so helpful, so maybe that was it. Find a mentor. This is always a big helpful thing. A mentor can kind of help you go from, you're shoveling your own snow to they say, hey, just move over 2 feet and there's like a sidewalk that's already been plowed. Just walk down that instead. And so they can be a really big help on teaching you and helping you like learn how to troubleshoot and get just better at troubleshooting and learning how to just be comfortable with like not knowing what the answer is and how to ask the right questions. Like, if you can just listen to the way a mentor troubleshoots sometimes in their internal dialogue of like, well, I want to know what this is and what the status of that is and the status of that is and the status of that is. And when I know that, then I'll be able to, have further information to know where to go to troubleshoot next. Right. And so kind of listening to how a mentor describes a problem and troubleshoots a problem really does help a lot at solving problems yourself. And to find a mentor, of course, your coworkers would be the very best bet because you work with them on a daily basis. You see them on a daily basis. If you can get someone to kind of get under, you take you under your wing there, that would be great. Otherwise, you can find mentors online by just going into forums, chat rooms, whatever, and just interacting with people a lot, even Twitter, and just say, when you see people that you really respect and admire and they resonate with what you're saying, just keep having chats with them. And if it kicks off, then you can, that could lead to phone calls or screen sharing and all this other stuff. And, it can be something special there. And then also going to conferences and meetups, that would also be a place where you can find mentors because this is where you're finding people with similar interests as you and meeting them in person. So lastly, I wanted to talk about getting better at all this. I mean, really what you're doing is just building your skill of being a better troubleshooter and being better at solving problems in general. And so when you get a problem that you've never heard of before, you've got a whole bunch of tools in your toolbox to try to figure out how to solve this. So one thing to, build your toolbox is to have like a lessons learned notebook of like, oh, here's how I solved this problem. When I couldn't figure out, like when I Googled it and it wasn't there on Google, how did I solve it? Well, let's write it down so that I know how to do that again. Or when I typed in the wrong command and it totally made a huge problem, what was that command I should never type in again? Or other commands that were very helpful, because you often don't remember, all the specifics and options that a command has that you used that last time. So writing down these things is really helpful. And, take it a step further, blog about it, put your notes in the public. And of course, scrub out any sort of sensitive information. You don't want IPs or even business names in this blog, but if you blog about it publicly, it's helping others. And when you're helping others, others have questions that you didn't think of answering. And they, trying to explain things to a public audience is also different than trying to explain it to yourself. Your own scribbles and notes are, you might be able to understand it, but when you want to try to describe that to someone, now you're helping others. And when you're helping others and you're teaching others, you really start to get that cemented in your head on how did I solve that? And why did this command solve it, right? You don't want to blog about like, well, here's how you solve it, but you also have that itch in your head of like, why did this work? Like, this shouldn't have worked maybe, but it did work. Why? And so then you start, diving into the whys and then blogging about that and stuff too, which really gives you a better understanding of the technology and the problems you've solved. And then, of course, you should take on bigger challenges. Like, you don't just solve all the problems as a IT engineer, and then that's done. You've got a notebook of how to solve everything. No, there's always new problems coming up. And so if you can be comfortable solving problems and tackling on problems you think are big and challenging, then you're just going to be better and better and better at handling bigger and more challenging problems, and bigger and more challenging and bigger and more challenging. And that's going to help your career just go right through the roof. So it's just really helpful to go through that and to take on those bigger challenges. So hopefully this has been helpful. I appreciate you listening all the way to the end, and hopefully you can solve novel problems more effectively. Thanks.